In all science classes, we ask students to define a problem, ask questions, develop and use models, plan experiments, analyze and interpret data, construct explanations, use math, draw conclusions, and communicate the information. To build an understanding of scientific phenomena, students need repeated opportunities to work and develop the fundamental ideas and interconnections for them to build a coherent view of a concept. This is done over a period of years, not during one class, not during one semester. For this to succeed, we must create a framework that emphasizes teaching with explicit connections from one level to the next. Our teaching must change towards a more deliberate, interdisciplinary strategy.
I think the magic happens in the classroom. I think there's nothing more magical than being in a place where a good teacher knows when their content which is in their heads is being delivered right to the student, and when the student gets it, there's nothing more beautiful than that. And I think enabling that across the board is hard, and requires a lot of practice. But getting everybody to speak the same language of claim evidence reasoning, if that's what the common thread should be, is not an easy feat. And so enabling that, or even getting close to that ability to create that magic in the classroom where we're all speaking the same language, students are being exposed to the same kind of authentic research experience or the authentic hands-on learning experiences within the classroom, across the board, not just in one class, right? And that, I think, is the magnificence of this project, and where this will go.
So when we were developing this project, my overarching goal or idea was that we would try to meet two different needs. The first was the need of the college to implement the competencies and have assignments linked to those competencies. The second goal was departmental, and that was aligning our courses and making sure that our courses were cross-talking and building on each other in a layered fashion, and that the assignments could play a role within the curriculum. And that's actually asking a lot, but I was hoping that we could meet those two demands and that they could actually complement each other, so that the college could still be able to test for its competencies, and as a department we could actually build this alignment structure from the college through the department and through the courses, and the assignments could be talking to both of those needs and addressing both of them.
Another positive aspect of this initiative is that we are connecting courses, and so students will be able to deduct reason. Making that connection is very important in General Biology 1 as well as in General Biology 2.
Programmatic integration has as its core the idea that student learning will be advanced when college competencies align with program goals which coordinate with the course goals. The course goals must correspond to specific assignments within the course which can be assessed. With these alignments in mind, the chemistry team is developing 3 new lab assignments for Gen Chem 1 with the aim of introducing students to modern computational approaches in chemical research using the core competency of inquiry and problem solving as expressed through digital ability. Using Gaussian for computerized molecular modeling will take students beyond molecular formulas and geometric shapes, enabling them to make the mental leap from 2 dimensions to 3-dimensional representations where hypotheses can be examined. These models are used to explain theories and rules besides contributing to the visualization of complex ideas, processes, and systems. The 3 labs are in sequence and will build on one another, enabling the students to interpret and analyze the data from Gaussian. Based on their interpretation of the molecular models, students will submit lab reports demonstrating an understanding of the concept beyond just the mechanics of using computational software. Our goal is to change the lab model from content instruction to content exploration.
This year-long seminar Natural Sciences Department ran on integrating the programs and aligning biology, natural sciences. This was very, very beneficial, and I think it's going to enhance the biology curriculum because it was very fragmented. And I think one of the things we've got out of this year-long workshop was really starting to, we always wanted to bridge the first year experience and the capstone. And it was always disconnected with multiple e-portfolios and lack of assignments scaffold throughout the intermediate courses. And so doing this seminar, we now have integrated and made key signature assignments that students will build upon from both chemistry, biology, and they'll scaffold this so that every other class moving forward builds upon what they've learned. And now when they come to the capstone, cell biology, they'll be able to have a more complete, holistic e-portfolio where we as faculty could also document the students' growth and learning, not only with the college's competencies and abilities, but also with what we would like to see them develop and grow as scientists. And they'll have this work to take with them in the future as they transfer to a four-year college, and we'll have this as a document, a holistic representation of their work throughout the time they were here, which we could use to assess the program and strengthen it even further in the future.